Hello guys, welcome back to my channel, and today we're just gonna cover all of this the left in chapter 2, and then we move on to chapter 3. So chapter 2 we only left these simultaneous linear equations with more than two variables. This one is not that important because it's just built on two linear equations. Now we have three, or we can have four, but once it's up to more than three, it's basically just use cats to help you to solve the expressions or solve the intersect. And just make sure you look at page 87 to have the idea, you know how to solve the system of equations, and make sure you use cats to help you to save time. Okay, and that's it. This is also not that important because the geometric of this thing, they never test in final exam according to this. Okay, so let's just move on to chapter 3, which is transformations. Okay, this one is actually covered in year 11, but most of students still find this one a bit tricky and difficult to understand. So again, I'm gonna introduce the topic first and some key concepts. Then for next video, we might use some final exam questions or use some example to illustrate my point. Okay. First, we all know translation is shortcut for T, reflection shortcut for R, and dilation shortcut for D. So DRT, right? So all other teacher gonna mention like Dr. T, right? So that's always the way we write, okay, and makes less complicated and easier. Okay. Let's first look at the translation. This one is most straightforward, just like moving to up and down and left to right. But just make sure like you know the point xy is the original point, and x dash y dash is the point which is new and is mapped from xy to x dash y dash. Okay, this is the first thing I want you guys to know, and you guys can check for page 99 to see how the things work. Okay, move positive one unit in positive x direction, one unit in the negative x direction, and one unit in the positive y direction, and one unit negative y direction. Okay, all will be the same. Okay, similarly. And next one is 3b. Okay, dilation. This one is a bit tricky because if we dilate it from x-axis, means we change the y value. Okay, if we dilate it from y x-axis, we change the x values. And some people are really confusing, like when should I times 2, or when should I times half, or when should I times 5, or times 1/5. We don't know. So that's why we need to use the method which is provided in the book, and to tell us if we should times 2 or multiply by 2. Okay, and this will be illustrated in this point. First, we know, look at question. This one is original, this one is a new one. So what I know is y dash is equals to 3 x dash. Okay, so once I got this one, I got my original function is y equals square root of x. So this one is pretty straightforward. We just make them corresponding equal. Then y dash equals y, 3x dash just equals 3. So my x dash just equal 1/3 of x. Okay, which means it's xy to 1/3 of x and y. Okay, so this is the corresponding to the first one from the y-x-axis. And of course, this dilation can always change in another way from x-axis, but just make sure we need to rearrange a little bit to be like this one. Okay, then we'll just see over here. So now again, use the coordinate method. So y just becomes root 3y. So which highlight two things here. The dilation factors, we can, if we write in the coordinate form, is pretty easy and straightforward. And another thing is if we write from different x-axis approaching, gives us the different values. Okay, this is called dilation. And next 3C, it called reflection. Okay, reflection, again, similarly, if we reflect it in the x-axis, actually we change y value. Okay, let's say for xy over here, any point my xy, if I reflect in the x-axis, it's become what? X negative y, right? So my y coordinates change, and if I reflect in the y-axis, like this one, so it's going to be negative x and y. So just make sure you never get this one wrong. Okay, otherwise we use coordinate method, it's going to be really struggle. Okay, keep going. This is the coordinates we use, and this reflect in the y-axis. So all of the A, B, and C is just do one transformation per time, okay? But now, actually, for the final exam, we do the combinations of it. Okay, we do combination of transformations. So this become tricky, and I had recommended you just follow my steps or follow the book steps to understand what is going on over here. Okay, let's look at this guy. Find the equations dilation factor of 2 from x-axis followed by the reflection in x-axis. So original point x dot y. First, dilate factor 2 from x, which means x to y. Okay, and followed by reflection in x, which means x negative to y. Done. That's it. That's how we use the coordinate to express. The next one is just like the algebra. Okay, so it's just x dash y dash. We just make x dash just equal to x, and my y dash just equal to negative to y. Again, this is the original function we have. Okay, y equals square root of x, but we want the relation is x dash and y dash. So we plug in x dash. Okay, y we just plug negative half y dash. So my y dash will be just substitute. Okay, it's negative 2 x dash. So at the end of it, we just get rid of the dash. So just y equal negative 2 times square root of x. Okay. And now you guys can pause the video over here to try part B, and then to see if you get the same thing with the result or the example solutions. Okay. And I will just go through these steps. The rest of the algebra you can do by yourself. So again, the first one is dilated factor 2 from x-axis. So it's xy becomes x2y. Followed by translation 2 units in the positive x directions, x plus 3, and 3 units in negative directions, y direction, so 2y minus 3. It's the coordinate method we will use. Okay, let's check. Yep, once we got this one, maps to x dash y dash, we'll just solve. Okay, use linear algebra. So question 6, example 6, use the same thing, and example 7, same thing. So you always can check. So I just want to talk a little bit more about determine the transformation. So basically, we know before and after, and I need you to help me to fix the middle. Okay, that's the idea of the 3E. First, find the sequence of transformation which takes graph y equal x squared to this y equal 2 times x minus 2 squared plus 3. So in here, it's just dash, dash, okay? So what I do will rearrange my new function, looks like this guy. So by it means I just rearrange x dash minus 3 equals 2 times x dash minus 2 squared. then I divide by 2 on both sides, I got this one. Okay, so now these two equations looks pretty similar. I just make my y dash minus 3 over 2 equals my y, and my x dash minus 2 just equal my x. So by doing this one, I got my x dash equals x plus 2, and my y dash just equal 2y plus 3. Done. So once I got this one, I can directly write the transformations from this. Pretty straightforward. First, dilution factor of 2 from x-axis, so I got 2y. Then positive 2 in x-axis, I got x plus 2. Then positive 3 in the y-x-axis, right? I got 2y plus 3. That's it. And now you can try for part B to use this method just to make sure always write the coordinate and to get this sort of ideas. Okay. Hopefully these videos can help you a little bit with transformations, and for next one we will go through some exam questions and to help you to emphasize my method or the method introduced by the book. Okay, and after that we will continue working on the chapter 3. Okay, that's end for this videos. Thanks for your time, guys, and if you like my videos, and please click like and subscribe, and I see you guys for the next videos. Bye bye.